Hey guys, in today's lesson we're going to go ahead and talk about um, the complex numbers and how we can write complex numbers in trigonometric form. But the first thing we got to do is we got to understand what the complex number is and how do we graph it on the complex plane. And this is very easy. Okay, so a complex number is made up of a real part and an imaginary part. So hopefully you remember that from Algebra 2. And when we graph it, much like when we graph it on an XY plane for real numbers, okay, we do the same thing with complex numbers. So the x-axis is the real axis, we call it, and the y-axis is the imaginary part. So if I wanted to graph 3 plus 2i, 3 is the real part, 2i is the imaginary. So you would go 3 to the right from the origin, and then you go 2 up. And that's it. Same thing over here. Negative 2 minus I, you go 2 to the left and then 1 down on the imaginary axis. Okay, and that's pretty much it. That's how you graph a complex number. Now there's one thing about complex numbers that we're going to have to be proficient in and working on. It's the absolute value. And the absolute value of a complex number essentially is the distance from the origin to that complex number right here. So essentially we're talking about this distance right here. Okay, just like that. Okay, so if you look very carefully, essentially we can draw this. We can do a right triangle. And if you think very closely, what do you think about when we think about right triangles? Yeah, Pythagorean Theorem. Okay, so essentially this distance is 3 units. This distance is 2 units. So if I wanted to find this distance from here to here, all I have to do is apply the Pythagorean Theorem, and I can find that distance, which in this case is called the absolute value. Okay, so we write it like this using a complex. So the absolute value of a complex number, okay, is this distance. All we're doing is we're doing the Pythagorean theorem, a squared plus b squared, and remember we got to square root it at the end, and that's it. So let's go ahead and look at some examples and see how we can do this and apply it. Okay, so we have this example here. It says plot this complex number, negative 3 plus 2i, and find its absolute value. So if you notice, I went 3 to the left, and then I went up 2 units. And that's the point right there. So what I have to figure out is this distance here. Well, Pythagorean theorem, a squared plus b squared, and then you take the square root of it. So because I went to the left is negative 3 units, and when I go up is positive 2. So we end up with 9 plus 4, which is the square root of 13. And that's it. That's your distance, the absolute distance of this complex number from the origin. That's it. Let's go ahead and see if we can do some examples here, nice and easy. Because this is fundamental as we move into more difficult aspects that we're going to be using with trigonometric form. All right, so from here, all right, how do we graph this one? Well, that's kind of weird because we don't have an imaginary, we don't have a real part, do we? Well, this guy is the same thing as writing 0 minus 3i. So the real part is 0. We're not going to move sideways, but we are going to move down 3 units. So 1, 2, 3. So this is the point 0 minus 3i, or just negative 3i. Okay, well then how do I use the Pythagorean theorem? Well, this is your a, and this is your b. Okay, so we want to go ahead and absolute value square root a squared plus b squared. Okay, what's our value for a? Well, it's 0. Okay, so that's going to be pretty easy. So 0 squared plus negative 3 squared. And you notice I only use the constant, not the I, okay, just the constant itself. Well, negative 3 squared, that's positive 9. And do we know the square root of 9? Yeah, it's 3. So the absolute value from the origin is 3 units. And that makes sense. If you can see from here, it's 1, 2, 3. Makes sense. All right, but sometimes it can be kind of confusing for students just because you say, I don't see a triangle, but not very difficult. All right, let's do some few more examples, guys. Nice and easy, okay? 4 minus 6 pi. So 1, 2, 3, 4 to the right, and then down 6. 1, 2, 3, 4, 5, 6 right here. Okay, so essentially what I want to do is I want to find this distance right here. So let me go ahead and just connect it here. Okay, that's the distance I want to find out. And essentially, guys, we have my right triangle right here. Okay, that's what we have. And this is a distance of 4 units. This is -6. All I have to do is apply the Pythagorean theorem, and I'm done. So let's go ahead and do that. Absolute value is equal to a squared, that's my 4, plus -6 squared. Notice how I did that, right? I'm always doing plus, but in parentheses I put the negative. And we'll go ahead and do it. Square root of 4, 4 squared is 16, 16 plus 36. Okay. And 16 plus 36. What is that? 3, 4, 52. All right, and there it is. That is the absolute value, or the distance from the origin to that point right there. All right, let's do some more. And you can just go ahead and leave it like that. It depends on your professor, but I think they'll allow you just to leave it like that. You don't have to go ahead and simplify it, just because we're talking about the absolute value, absolute distance to that point. Number 4, 5 plus 2i. So we're going to go 5 to the right, 1, 2, 3, 4, 5, and go up to right here. So this is the point 5 plus 2i. All right, so we're talking about this distance right here. All right, and if you notice, there's my triangle right there. So same thing, absolute value, that distance, square root, okay, 5 squared plus 2 squared. And that's easy. 5 squared I know is 25. 2 squared is 4. All right, that's going to give me 29. That's a nice, good number. And that's my answer. Nice and easy. Okay. And we'll do one more, guys. Same thing. Now this one we're going backwards. I try to do one in each quadrant. So -4 is 1, 2, 3, 4. And then we go up 1 right here. Okay. And here it is. All right, we want to find out this distance right here, this z, absolute value of z. Okay, so we'll do it again. Okay, and don't forget your square root. So it's -4 in parentheses squared plus what's in front of the I, that's a 1. 1 squared. Okay, so then we get 4 squared is 16. 16 plus 1 is 17. So our final answer is the absolute value is the square root of 17. So hopefully that makes sense, guys, and this is very important as we move on to more difficult concepts. But if you understand this, you're on your way to understanding these trigonometric forms of complex numbers. All right, guys, see you guys next time.